GMAT triangles theory you need to know.
There is a relationship between the lengths of the three sides that form a triangle, so that the length of any of the sides can never exceed the combined length of the other two. Otherwise, you would have a likely situation like this. Imagine that you want to form a triangle with these three segments. Impossible, right? Because these two together cannot even reach this length. So this is expressed with a double inequality that you can apply to any of the three sides of a triangle. Each side must be less in length than the combined length of the other two, and it can also be considered greater than the difference of the lengths of the other two sides. So for example, if they tell me that the side of this triangle is 5 and this is 9, then it follows that A must be less than 9 plus 5 and greater than 9 minus 5. The range of values for this side A would be between 14 and 4. There are many types of triangles: equilateral triangles, isosceles triangles. You learned this in elementary school, right? The equilateral triangles, all three equal lengths and three equal interior angles of 60 degrees each, while an isosceles is a triangle with two equal sides and two equal angles. The right triangle is a triangle with a 90-degree angle, and the two sides that form the right angle are called legs, while the greatest angle, or the longest, is called the hypotenuse. The right triangles in the GMAT are very commonplace, and especially these three you see in the slide. The first one is the right triangle that you can obtain when you have a square and draw its interior diagonal. You have two triangles of the same shape. The isosceles right triangle. Take a look at the proportions of the sides and the two angles of 45 degrees each. There is another triangle with three sides that are proportional to the numbers 3, 4, and 5 in their respective lengths. There is another triangle that has these special proportions, but two interior angles of 60 and 30 degrees. This is what you get when you have an equilateral triangle, for example this one, and you draw the height of the triangle. What is a height anyway? A height is a perpendicular segment that you draw from one vertex to the opposite side, but perpendicularly. If you don't match the triangle in your question with any of these three, perhaps you can use the Pythagorean theorem to solve the unknown sides. After all, if you have the length of two sides in a right triangle, using this relationship, you can always solve the remaining or the third side. What about the area of a triangle? This is the perhaps most well-known formula in the universe, right? Who doesn't know what is the area of the triangle? But be careful, because when you talk about the area of the triangle and the concept of base and height, remember that the base is simply any of the sides, and the height the corresponding length of a perpendicular segment drawn from the opposite vertex. So you can see that the height could be within the triangle, could match one side of the triangle, or could be actually totally outside the triangle. It depends on the shape of the triangle and on the vertex from which you draw this segment called the height. There is a special formula for the area of an equilateral triangle based on the length of the common side. So all you need is to do this: square it, multiply it by the square root of 3, and then divide by 4. Then you get the area of an equilateral triangle. What else can we say about triangles? Triangles, similarly as other polygons can, they resemble other triangles. That is to say, they can be proportional or similar to other triangles. What we said last time is that two polygons are similar if all their corresponding sides always follow the same ratio. Triangles are no exception to this rule. So if you have, for example, that two triangles have this same proportion for all their corresponding sides, Well, that means these triangles are proportional or similar. And you can always identify what the proportional sides are or the corresponding sides are because they need to be opposite to the same angles. For example, here, the opposite angle to this side A should be alpha. So here must be alpha 2. If here is beta, here should be beta 2. If here is gamma, you should have gamma here. You can establish proportions using sides that are opposite to the same angles. And this you can use to solve unknown segments or lengths in a figure. For example, here, how do we find x? Notice that these two triangles in the figure are proportional because they possess the same three angles. So you can say that those sides opposite to the angle alpha in both triangles for an x are, directly proportional as the lengths opposite to angle delta, which are 8 and 8 plus 6, that is this combined length, 14. So you can establish always a direct proportion that can be used to solve any unknown segments. Triangles possess an interesting property regarding their exterior angles. What is an exterior angle anyway? If an interior angle is, for example, alpha or beta, an exterior angle is the supplementary angle for any of the interior angles. For example, this is the exterior angle in this corresponding vertex. So in this vertex, there is an interior angle, let's call it gamma, but the exterior angle is this. Well, there is this property that says that the exterior angle to any of the vertices of a triangle will always match in measure the combined measures of the other two interior angles of the triangles. So you can say that this supplementary angle here must be alpha plus beta. Why? Because gamma plus the supplementary angle is supposed to be 180 degrees. And as you know, from this theorem, the sum of the interior angles of any triangle is always 180 degrees. So it's no wonder that this measure is 180 degrees minus this, right? Exactly as indicated in the figure. So you can here see another example. Here is another angle gamma, and the exterior angle should be the sum of this and this. The property of the median of a triangle says that if you have a triangle and you draw a segment connecting one of the vertices of the triangle with the midpoint of the opposite side to this vertex, then that segment is called a median. And a median has the property that divides the whole area of the triangle into equivalent areas. So you can see the original triangle is divided in two. These two triangles, they don't look the same, right? They have different shapes, but their areas must be the same. That's a property of the median. Okay? Remember, this is a midpoint. That is to say, is halfway between this vertex and this other vertex. And that's it. That's what triangles are all about.